Okay, so basically this is a video about EIGRP overview video, and it's gonna be a trying to make it short video. So we're gonna talk about the first. So let's get it started, and let's go to the second point. I will skip the first point because first point is actually talking about fourth point, so we'll cover that later. And we talk about the conditions for two routers to form neighbor adjacency. So basically the first thing you have to get right is the AS number, which is basically the router EIGRP, that number that you configure both routers to form a neighbor. That AS number has to be the same. And secondly is the subnet of the interface. So to ensure that both routers that is connected to each other, that interface, that has to be in the same subnet. If not same subnet, then there will be no neighbor. And lastly is and thirdly is you actually put network command for the interface to enable EIGRP. So if the interface is not enabled for EIGRP, obviously there's not going to be any EIGRP neighbors. And fourthly, it's passive interface. So if you actually passive the interface towards the other neighbor, passive interface is gonna deny sending out of hello packets. So you're not gonna, if no hello means no neighbor, so you're not gonna get any neighbor if you have passive interface. So this is the conditions for two routers to form neighbor adjacency. And thirdly, we'll talk about how to calculate EIGRP composite matrix. So this is the composite matrix. This is actually not the full matrix, but this is the default if you actually didn't configure anything, and you actually take the lowest bandwidth and the sum of all delays and multiply it, and it will become the distance that EIGRP calls it as. So if you're wondering what is the lowest bandwidth and sum of all delays means about. Right, so make a topology. A simple one will do. I think this suffices. Yeah. Can you actually make? Oh, never mind. We didn't do that. Okay. We'll just ignore this thing right here. Name this 1, 2, 3, and this is a LAN, and it's connected to 1.1.1. Okay. So R3 is when advertising to R2, and R2 is going to advertise the network of this to R1, it's going to calculate. So how it's going to calculate? So if you look back here, it says the lowest bandwidth and the sum of all delays. So R3 is gonna have its own. So basically EIGRP uses bandwidth and delay. So let's say the delay of this is 1000. I'm just making things up, so this is not the full equation actually. So let's say this is a 10 gigabyte interface, which is going to be 1 actually, because it has to divide 10, and it's going to take this information and calculate its own feasible distance in this network, and it's gonna advertise this to R2, and let's say this bandwidth is KBBS actually. Put it down here. Okay, so this delay, let's say it's 2000 actually. So the delay will be 2000 plus 1000, because like I said, it's the sum of all delays. And bandwidth, I'm gonna take the lowest link. So the lowest link is 2048 kbps. So I'm gonna take these pieces and put inside this the EIGRP formula and calculate my own formula and come up with the feasible distance to reach this network. Then it's going to do the same, and let's see, this 124 kbps. Yeah. So let's say this delay is going to be 4000, and this is going to add up the delays. And by the way, this is just making things up, so don't take these things into account. So it's going to take this information. So now is the sum of all delays of all links to reach this network, and it's going to take the lowest bandwidth. So this bandwidth is going to be taken into account, these two values, and put right inside this formula and calculate. So yep, that's how you calculate the composition matrix for 1.1.1 network.